On the world's largest island sits the world's second largest formation of frozen snow, the Greenland Ice Sheet. Only Antarctica holds more ice. Covering more than 500,000 square miles of bedrock, the Greenland Ice Sheet is as big as Alaska. In some places, it's 1.5 miles thick. Scientists know that this massive ice formation is melting. What they don't know is how fast it's melting, or how far it might recede as the planet warms. That's what oceanographer Joe Stoner wants to find out. The marine geologist at Oregon State University is sending his research team to Greenland to look for clues in the geologic record of the island. Those clues are hidden in ancient sediments, silts and sands pulverized over eons by glaciers grinding over bedrock and rivers rushing toward the sea.
We have obtained records in the past from sediment cores in the ocean that give us a long-term history of the Greenland ice sheet, and they suggest that during previous interglacials, or times similar to present or even warmer than present, that the ice sheet has melted substantially. And we are trying to better understand that and see if we can actually track it, find out what parts of the Greenland ice sheet are melting.
The researchers call these clues fingerprints.
So we're going to be looking at the magnetic properties from those sediments. Changes in magnetic concentration or grain size or mineralogy can be diagnostic of where materials come from. And we have found that there is a strong magnetic signature in the ocean associated when Greenland is rapidly deglaciating. So we want to really see if we can track that and fingerprint where the material is actually coming from, so we can see how much ice loss has actually occurred. How fast has Greenland ice sheet basically pulled back beyond certain limits. So we're going to use those as sort of fence posts as to see if Greenland moved back beyond this, then we might get this material. If it's moved this far, we might get this material.
Professor Stoner's postdoctoral research assistant, Rob Hatfield, will be joining scientists from the University of Wisconsin on the southern tip of Greenland this summer.
So my name's Rob Hatfield. I'm a postdoc here at COAS in OSU. I did my PhD in Lancaster University in the UK. I did a postdoc actually last year in Canada working on sediments in Lake Erie and looking at sediment moving off the Greenland ice sheet into the North Atlantic to try and reconstruct what's happened in the past. So if we know what's happened in the past, we can kind of project that forward to what's happening in the future.
If the Greenland ice sheet were to melt completely, sea level would rise more than 7 meters worldwide. That's almost 24 feet.
That's more than 20 feet of sea level rise, which you can imagine is a substantial level. And most of our coastal developments would be gone, or we'd have to build huge dikes around the whole country, which would cost billions and billions of dollars to try to deal with this issue. So if Greenland ice sheet were to melt and we were to get the 7 meters of sea level stored in that ice were to happen, we would have a substantial rise in sea level, and a lot of coastal environments and places would essentially disappear under the seas. Whether that be Portland with sea level rise coming in through the Columbia, Miami Beach, Manhattan, a lot of these places would essentially disappear.
The impact of Greenland's meltdown would be global. Coastlines across the planet would be submerged. Millions of people would be displaced. So it's with a sense of urgency that the OSU scientists are heading to the rocky shoreline of this remote research site.
So we're actually flying to Greenland via Albany in upstate New York. We're flying with the Air National Guard, which would be quite nice. We're getting a Hercules C-130 transport plane. We're flying via Newfoundland, I think, for a refuel, and then we're flying, as I was showing you before, into Kangalusak. So it's here on the kind of the western coast of southern Greenland. So here you have kind of the Greenland coast, and this white mass obviously is like the big Greenland ice sheet that a lot of people are worried about now at the moment for climate change. We're mainly going to focus on this southern portion of Greenland here, because this is the area that people think this ice was lost most from 125,000 years ago, which was the warmest period that we kind of look at on record.
PhD student Sarah Strano is another member of the research team.
So my name is Sarah Strano. I'm originally from upstate New York, and I was actually living in France doing research before I came here. I was working on reconstructing climate in Mongolia through lake sediments, and there were some people who were using paleomagnetism to do similar things in Mongolia. We're going to be joining a group of 3 scientists from the University of Wisconsin-Madison, and we're actually going to be sampling stream beds from a variety of locations. So we're going to be sampling stream beds for both magnetic properties as well as for chemical analyses. And we will be flying into a lot of places that I cannot pronounce very well. And we are taking these sediment samples so that we can match them with marine sediment cores that have been collected. And we can actually use those sediments as they're like magnetic fingerprints, so we can compare them very easily.
So if you look at some of these rivers here, you can see the draining almost directly from the ice sheet, flowing down these river systems. And if you can imagine what a river system would normally look like at home, it'd be quite clear almost, in nice clear waters. Here, if you look at some of the colours of these river systems, you can see how milky they are and how chalky and how choked with sediment they are. So this is kind of a nice area to look at, really, to try and gather some of these sediments. We can look at the actual processes of how sediment is getting from the ice sheet and erosion into the river system and then actually out onto the deep ocean basin, where we can kind of try and fingerprint these studies from there. And you can see actually all of these river systems, all of these fjord systems that could potentially feed sediment from this ice cap, underneath the ice cap, out into the deep ocean basin. So what we've got here are three different sediments, really, from 3 different regions of Greenland. We've got kind of this light grey type sample, this deep red sample, and this more brown kind of coarser sample. So what we're trying to do in Greenland is we're trying to collect these different sediments from the 3 different geologies, 3 or 4 different geologies that make up the southern part of Greenland. And we can measure the properties of these, so the magnetic properties and also the geochemistry. So they're trying to work out the differences, really, between the 3 different sediments. The theory is if we can create almost a fingerprint of each kind of sediment, so tell them apart and give each sediment a fingerprint almost like you have on your hands, we can start to tell them apart in different environments. So if we could look at a sediment core, for example, off the southern end of Greenland, out into the ocean, and we can find sediments from one of these geologies or all 3 of these geologies, we can start to work out how big ice volume was in Greenland at the last glaciation and previous glaciations and kind of project that forward to the future.
To read the fingerprint, what geologists call the magnetic signature of each sediment sample, Professor Stoner will use a powerful instrument called a magnetometer.
Well, this is basically a new generation superconducting rock magnetometer designed to measure the very weak magnetic remnants in sediments. It's very much state-of-the-art. That pulsing that you may or may not hear at the background there is related to the helium compressor that's on here that takes this down to 3 degrees Kelvin inside here, so that we can measure the magnetic moment by pickup coils that use superconductivity and use these devices called SQUIDs, superconducting quantum interference devices, to measure the magnetic moment. The unique thing about this is it has this tracking device here, which allows us to measure sediments like we have here at 1 centimeter intervals, and it's automated, on a track, computer controlled. So we can take this and run it through and make a measurement every centimeter down a sediment section. It's one of only 3 or 4 in the United States at present, and the second one of this new liquid helium-free generation. So it's really something that's completely unique to the Pacific Northwest, and one of the few in the country, and really the few in the world.
When the sediments have been collected and analyzed, the researchers expect to have a better picture of how the Greenland ice sheet has fluctuated over geologic time and how climate change may affect it in the future.
It should give us an idea of how stable or unstable the Greenland ice sheet is. So we can look at conditions where temperatures have been observed and predicted to try to, assess its sensitivity to future warming. Is it going to contribute, a half a meter in the next few centuries, or, try to get an idea of its basic instability. Without the marine record, we have a very short record. So we need to go to times warmer than past. Now, these were a long, long time ago. These were 120 or 30,000 years ago to find these times, or even farther. So we have to go quite a bit into the paleo record to get these sort of records.